The topic that we are trying to address today is 3D printing of buildings. Whether you can call it as 3D concrete building technology and its possible applications by military engineering services. Now, we can look at it as the concept, the applications and the merits, the adaptability and the constraints. Therefore, when we look at a design, sometimes you have a freedom for design, sometimes you have limited design freedom, sometimes you don't have freedom at all. It can so happen that occasionally you don't have design freedom because you don't have the wherewithal to execute the design. Otherwise, a designer is always a free-flowing man. The sky is the limit. You go to Hafiz contractor or you go to anyone of great name and fame, they will come up with a design every hour. That is the creativity. But then entail so much of form work, so much of preparatory work, so much of material to execute, and definitely there will be a high labor cost, there will be a high material cost, there will be a high project finance in total. When you go for exorbitant designs or what you call as designs that will entail some expense. Occasionally there are designs which can actually play a part in the facade, play a part in the functionality, where not necessarily one would have to spend greater cost if one can find a technology that can lend itself to bring shape to the design without much fuss and ado. In technical terms, without much need for form work and without much need for separate costing, without much need for too many joints, without much need for different stages of construction. So what are they? Aluminium formworks. One of the companies for that is Maivan, the European company which was adapted by the Malaysian major and then brought in, and now there are so many other companies making the same type of aluminium formworks. Now aluminium formworks, there are a number of standardized aluminium formworks which you buy as a set, which can lend itself to say 250 usages, 300 usages. Generally they say that max 250 usages, and when you use it for so many number of times, there is economy of scale, cost will come down. But then there also, if you have a typical design in mind, you can make custom made formwork. And when you make high speed concrete flow inside, it finds its spaces, places, crevasses, it fills in. So there can be a rolling ceiling, there can be all forms of triangles and rectangles and parabolas wedged in. All of that is possible. But then for that, you will need to create a formwork. And that formwork, when you use it a number of times, you are going to reduce the labor cost, and with economies of scale, you are going to find it useful in long term. On the contrary, when you look at a 3D printing is a simple philosophy of a machine which takes an input, say from an AutoCAD or say from a drawing, some electronic input of how the structure is going to come up, how it is going to look, and the input issues out into ink. Here the ink is a metaphor for the concrete mix that is flowing in from the nozzle. So like you make a jalebi, the nozzle starts moving and you have ensured that the robotic movement is perfectly controlled as per the input, and the movement starts adapting itself to exactly the input that it is receiving, and hence you start seeing layer after layer after layer after layer. It lays the concrete to create modules. The modules can be coded, named as A1, A2, A3, B1, BA1, AB1. So various parts, like a LiDAR software, various parts of the particular building can be broken into modules, and then coming to first an off-site printing off the site at a hermetically sealed place with a gantry, with a huge cabin, with enough headroom space where the 3D machine has been installed. The machine is able to lay as per the input modules. The modules can be transported to the site, and module after module, they can be pasted, supported together and monolithically brought into a whole structure. Now here design freedom is tremendous. Look at on-site construction. You can erect a huge gantry or supporting structures wherein the machine finds its freedom to start casting exactly the input that it is receiving without the need for breaking into modules and shifting it from off-site to on-site. Differences, benefits are so obvious that when you go for an on-site printing, the design is given shape to at the very site, ab initio, without much ado, but constant supervision and liberty of an unencumbered site, without much disturbances of wind, of storms, of dust, of pollution, of manpower moving here and there, of traffic. So you need to get such kind of a site, and you need to be able to take the machine to that site, erect the machine in that site. Whereas, should you have a machine which is installed at a particular place, which is probably in a commutable distance, where you have got a sealed atmosphere, a gantry is already there, electric supply is there, a mini quality control team has been established, shifts are arranged, 24/7 you are able to print. At a time you can take 4 or 5 sites, and modules can be printed and sent to each site and fixed at each site. So it is all a question of the model that you work out based on the labor cost, the finance cost, material and transport cost, all put together in a matrix. Therefore, you need to have the benefits very clear in the mind if you want to go for a technology of rapid construction like 3D printing, wherein you will have controlled deposition based on a pre-planned and accurately planned and wisely planned method of what needs to be constructed and how. Then you start printing. Enough design freedom is there. Minimum formwork will be required. Hardware and software get integrated in the lab where you are printing it, or at the site when you are printing it. It's a mini automated construction wherein, except for filling the conduits with pipes and wires and fixing the crevasses and the spaces, the recesses with your fitments, the construction is faster. Quality control can be robust because the whole civil engineering revolves around obtaining a design mix and coming to a site and implementing the design mix and ensuring that the aggregate input, the cement input, the water cement ratio and the mixing, the agitation of concrete, the flowability, everything remains exactly the same way ad nauseum, point after point, day after day in the same quality. Whereas if you have a off-site printing facility or an on-site printing facility where there is so much of hardware and software integration, you can even feed that if so much of malleability, ductility or flowability of the contract is not achieved, you can program that machine to stop, it will stop. So it's all about robust quality control which is achievable here. Not to say that it is not achievable elsewhere, it is more easily achievable here. So what had happened recently is the COVID pandemic. In such situations, there are a few difficulties in supply chain, in quality control, in specific manpower, in specialized manpower. In 3D printing, all you need is a particular small team which can be stationed ab initio in a particular place for long hours, and the moment that initial setup, which is costing a bit, is in place, production can continue on and on. Therefore, the very idea of 3D printing, let's go back and see. It was born in 1983. Charles W. Hull was the man who led the invention of stereolithography. So 3D printing initially was not necessarily for concrete constructions. For all kind of, you wanted a orthodontist, a periodontist, a dental expert wanting a particular piece, it can be exactly 3D printed. When COVID pandemic struck you, even the face masks, the covers, so many things could be straight away 3D printed. 3D printing is used for aircraft components. Speak to people in Airbus, Boeing, for accurate look at Tatas in their rolling mills. There were parts which were 3D printed. Could be any industry. They all started looking at 3D printing for the past 2.5 decades very effectively. Initially, it looked complicated and expensive. Later on, the benefits started coming out. The usage spread to various fields, medicine, automotive, aerospace, etc. Fused deposition modeling, basically, which I was trying to put across so nicely as a jalebi printing. It was invented in 1988. First 3D printed house was constructed in Amsterdam in 2014. In India, at IIT Madras, a startup attempted the same and made a house, the first house, 2 years back. In the military engineer services all over India, in all the services, the first 3D printed set of houses for Jawans was constructed at Southwestern Air Command by team Gandhinagar Zone under the guidance of Engineering Chiefs Branch, wherein the ENC, who kept going to places could see that there is a need for rapid construction, because gestation period in construction engineering is too high. You cannot everywhere wait for endless number of months for buildings to come up. There is a need for rapid construction, and as a test case this was attempted, and within 30 days 2 fully mature, properly foundation and roof given modules based zone 3 earthquake resistant with superior finish and rich specifications, 2 houses were born, and the contour crafting was most promising. We will be showing you a few pictures as to how it came about. In between, I mentioned about stereolithography. It's a form of 3D printing technology which was used for creating models, prototypes, patterns, production parts, etc. Therefore, we look at a mechanism in which ductile material, here the concrete, is extruded through a nozzle, and the nozzle listens to the feeder which tells the nozzle as to where all it should move and how it should pour the concrete, and it is ensured that the concrete doesn't set too fast, doesn't set too slow. So each 3D printing startup starts speaking that they have got a particular formula for the concrete which could be using additives, etc. But then the point is, whatever admixture they use, the concrete has got a certain strength which can be seen visibly. Generally they use M25 or M30. Thus, look at the process once again mentally. First you make a design. You understand what is the 3D printing going to achieve, and then you slice it into parts. The CAD software made model, CAD model, is broken into layers, converted into an STL or an AMF file. Then it is printed. It involves a transfer, the positioning and printing using the nozzle layer by layer, layer by layer. Post processing, you have to cure it, ensure that some carrying facility is given, and it could be slots, it could be cleats, it could be sleeves, it could be reinforcements bent. Then ensure that it is taken safely and used modular by module for construction for an off-site printing. For an on-site printing, ensure the same process takes place without transportation, without module by module, by going straight away from step by step, layer by layer. Now, if you look at the applications, it could be used in manufacturing, medical, like I had brought out, in industrial applications, in socio-cultural applications, in manufacturing, in additive manufacturing. This is an additive concrete manufacturing. Mass customization is possible, rapid. In medical applications, for bioprinting, for devices, in industrial applications, like obviously construction is for industrial application, otherwise you can use it for computers, for robots, for automotive industry, for socio-cultural applications. Gentlemen, you can make facades without making a formwork. The architect can suddenly think of a particular kind of a shape to be given to the portico, or to the garage, or to the fascia of the building, or he would want to make a look different, because finally a building which is well finished is equally important as a building that is well constructed. Distinctly different points. Aesthetically, when a building is more appealing, it creates much better customer satisfaction than just the quality being good. Here both are possible. Further, when we look at 3D printing technique as a novel construction technique, as a fastest growing construction technology, where layer by layer digitally you are able to think of something, print it and bring it to life at a particular site, there is also a need for you to have a look at a 3D printed house, because seeing is believing. So let us, in a small little video, see how this particular house which I had spoken of had come up. Now, are all houses possible of only one story? No, a 5-story house was tried out in China in 2015, but I haven't been able to go to China, neither many of you. There is a G+1 which was tried out by L&T somewhere, but it is just a work in progress. They haven't finished it. It was in Kanchipuram, if I remember correctly. There was a house printed by Winsun Company in China in 2014. A number of houses are being printed in the UAE. There are companies in Netherlands. There are companies in Germany. There are companies in US. Further, when you look at the startups in India, definitely L&T is trying to get into the space very fast. But then per se in startups, I will quickly mention Twasta, a startup which has been supported by IIT Chennai, Madras, and MyCups, a startup which has been supported by IIT Gandhinagar, and there are many more who are entering the fray very, very fast. Gentlemen, it's important for us to look at a technology holistically and understand it if it can really support us in our ventures. Let us say we need to prepare 100 garden benches, much easier through 3D printing. What about the reinforcements? What about the bonding? What about the tensile strength? What about the shear strength? What about the lockings in the corners? What about the conduits? What about the thickness of the wall? What about reinforcement? Should it be done at site or should it be done during printing? Or even in offsite printing, should it be done during printing or should it be brought to the site and then done? For all this, I recommend you refer to our video, our e-module in form of a panel discussion on 3D printing which we had done the other day. Thank you.